Hey everyone, welcome to today's video. So I have been getting so many. It's definitely the most requested topic ever. So many requests that I film a geometry SAT video. So I have pulled the craziest, hardest, weirdest questions that I could possibly find from the SAT math that are directly testing geometry, some weird concepts, some difficult concepts. So if you need help with geometry, this is the video for you, so stay tuned. And without further ado, let's get into today's video. All right, so this question is gonna be a great time. Let me just preface it with that. There are a lot of steps involved here, but it is not impossible. I will show you how to do it. You can see that what I'm highlighting here in yellow and what I'm highlighting here in yellow, these are both radii because we can see that they descend from the center of the circle all the way to the rim. So these are both radii, so that means that they are equal in measure. So I'm going to go ahead and indicate that by those little ticks. All right, so what I know then is that I can drop a line down here and make this into two triangles instead of this weird looking four-sided shape. So that's definitely going to be my preference. And then they tell me that right here, LM and MN are tangent to the circle. So to be tangent to the circle, it means to form a 90-degree angle with the circle. Alrighty, so let me just draw this in as being 90 degrees, and this is 90 degrees. But we can see right here that this triangle that I'm highlighting in green, well, I know that if LM and MN are drawn tangent to the circle, that LM is equal to NM right here. So we basically have two sets of either isosceles or equilateral triangles depending. So let's check this out. So within a given triangle, the angles have to sum to 180 degrees. So in this green triangle right here, we've already occupied 60 degrees, which means that we have 120 degrees remaining. That's just 180 minus 60 to get that. Gives us 120 degrees. And we know if this is an isosceles triangle, the angles that I'm going to draw here in red, this one and this one, have got to be equal to each other. So 120 split equally amongst those two angles makes them each 60 degrees. So let's go ahead and write that in. This is 60. And this is 60. But we know because LM and MN are drawn tangent to the circle that this whole angle right here has got to sum to 90, which therefore makes this angle in here 30 and this angle in here 30. And that leaves us for this angle, again, if we know that the angles have to sum to 180 degrees, this is 30, so we subtract 60 and we get that this angle right here is 120 degrees. So the central angle right here is always going to have the same measure as what its arc extends into. So the arc is also 120 degrees. It's associated with 120 degrees. So we know that if the circumference of the circle is 96, the circumference of the circle refers to the entire rim of the circle. So let me just draw another circle because we obviously got a lot going on here. All right. Let me actually draw two. So we know the circumference corresponds with the entire rim of the circle, and a circle in total has 360 degrees. We're trying to find, though, that arc right here. They want to find arc LN, and we know that that only goes with 120 degrees of the circle, which is 1/3 of the total degrees of this circle. So if we just take the total circumference of 96 and we multiply that by 1/3, we get that minor arc LN is 32 as the length. Alrighty now, guys, let's check out number 31. So we're told that H comma K here is the center and that the radius is 10. All right, so the radius is basically just any line that extends from the center of the circle all the way to the rim. So both of the lines that I'm drawing right here, navy, are considered radii, and those are equal in measure. We know that these are each 10. All right, and then this side that I am drawing in red right here, we know how long it is because it goes from x is equal to 4 to x is equal to 20. So it's a difference of 16. So this is 16. So what we can do right here is we can drop down a line from the center and create two different triangles right here. So if this whole big red side is 16, that means that this part's going to be 8 and this part's going to be 8. It's going to be split equally into two. So we need to know on the SAT two Pythagorean triples that they're going to test us on. We need to know that a 3, 4, 5 right triangle is a thing, and that a 5, 12, 13 right triangle is a thing as well. So a 3, 4, 5 right triangle is the same thing as a 6, 8, 10 right triangle, because that's just the same thing multiplied by 2. Or as if we multiply by 3, a 9, 12, 15 right triangle. So we can see right here we have a 10, 8. So that's exactly the same proportion that we have for 3, 4, 5. So if this is 10 and this is 8, that means that this side right here, the missing side, let's do that in pink, has got to be equal then to 6. So if this is 6, that means that the value of k right here, because y right now is 0, 0 plus 6 is equal to 6, so k is equal to 6. All right, looking at this other circle question, they tell us that point P is the center of the circle. What is the value of x? Okay, so this is something that we definitely need to know. This will not be provided. What we need to know is that an inscribed angle, this angle right here that I'm coloring in blue, is equal to half the measure of the central angle, which here is x. So this is technically then 1/2 x. We can label that as that. We already know that this is 20 and this is 20. And we know that a circle in total, let's do this in red, has 360 degrees total. So if this is x, then this angle that we're drawing right here in red, the remaining part, has got to be 360 minus x. So now we've expressed all of these four angles right here, whether that's with variables or with actual numbers. And what we need to know about any four-sided figure, we can see right here that the figure we are working with has 1, 2, 3, 4 sides, oddly shaped, of course. We have to know that any four-sided figure, the angles inside have to sum to 360 degrees. So let's set up an equation to express this. So we have 1/2 x plus 360 minus x plus 20 is equal to 360. So let's go ahead and combine all of the like terms here. So 1/2 x minus x is equal to negative 1/2 x. 360 plus 20 is 360 plus 40. That's plus 400 is equal to 360. So subtract 400 from both sides. We get the negative 1/2 x is equal to negative 40. So what we can do here is we can multiply both sides here by negative 2, because that will remove the negative and the 2 right here. So negative 2. So we get then that x is equal to 80 as our final answer. And last, but certainly not least, I have saved the best, the craziest for last. One of my tutoring colleagues has coined this question, the hexagon of death, so I've labeled it as such right here. So let's talk about how to do this question. So they tell us that it's a regular hexagon right here. So if we know that it's a regular hexagon, what that means then is that all sides are equal. And they tell us that the sides have a length of A and the square also has a length of A. So this is A, this is A. I'm just going to label all of these guys as A. All right. A lot of A's here, of course. So they tell us that the area of the hexagon is 384 rad 3. And then they ask us for the area of the square. So we know the area of a square. So let's write this. A square is equal to the side squared, which in this case is just going to be equal to A squared. So what we're going to need to do is find A, and then it will be relatively easy to find the area of the square. So before we can do that, though, we got to deal with this hexagon of death, as they say. So, all right. So there are a few things that I always see students try to do for this one. You could try to like cut it into two triangles in a rectangle, but that really doesn't help you too much. You can also try to make it into two trapezoids, but you don't know what the height is and you don't know what the second base is, so that's not going to help. So the best thing that you can do here is to realize that you can take this and slice this into 6 different equilateral triangles, kind of like a weirdly shaped pizza, of course. We're going to draw in little pepperonis. So these are all equilateral triangles, which means then that all of their sides are equal to A. I'm not going to write a million more A's, but every side in this little web is equal to A. And the formula for an equilateral triangle is equal to radical 3 over 4, and then the side squared. So in this case, the side is equal to A. So A squared. Okay, and we know that we have, let's count how many. We have 1, 2, 3, 4, 5, 6 of these. So the area then of the hexagon is going to be equal to 6 times this whole thing that we got going on right here. All right, so let's go ahead and simplify this with what we can. Let's go back to blue. So we get then 6 rad 3 over 4, A squared is equal to 384 rad 3. Alrighty, so what we can do first is multiply both sides here by 4. Again, we do have a calculator, thank goodness, because I cannot do that without a calculator. I mean, I guess I could. It would just take, obviously, a really long time. So this becomes 1536 rad 3 is equal to 6 rad 3 A squared. So we can divide both sides now by 6. So divided by 6, that gives us 256 rad 3 is equal to rad 3A squared. We have a rad 3 on both sides here, so we can go ahead and cancel that out. So we get that 256 is equal to A squared. We don't even need to solve for A though, because remember what I said up here, that the area of the square is equal to A squared. So that means then that the area of the square is 256, or choice A. Thanks so much for watching, guys. Hope you enjoyed and learned a lot about all of the very fun and exciting geometry that appears on the SAT math section. Again, if you enjoyed this video, make sure to thumbs up, subscribe, and leave any comments for requests or, just saying, hey, Jackie, you're a pretty cool girl. Totally kidding. And again, guys, make sure to follow me on TikTok. Test Prep Tips is the handle. Thanks so much, guys. Take care.